Physics theory and practical course will be done in 2 terms. Each terms will be assessed individually. Syllabus assigned to term 1. Theory course structures. Time is for 90 minutes and maximum marks 35. This is for the term 1. Unit 1. Electrostatics. Chapter 1. Electric charges and fields. Chapter 2. Electrostatics, potentials and capacitance. This will be 17 marks. Unit 2. Current electricity. Chapter 3. Current electricity. On the total marks, Unit 1 and Unit 2 will be 17 marks. Unit 3. Magnetic effects of currents and magnetisms. Chapter 4. Moving charges and magnetism. Chapter 5. Magnetisms and matters. And Unit 4. Electromagnetic induction and alternating current. Chapter 6. Electromagnetic induction. Chapter 7. Alternating currents. The marks will be 18. So total marks will be 35. Unit 1. Electrostatics. Chapter 1. Chapter 1. Electric charges and fields. Electric charges. Conservation of Church Coulomb's law. Force between 2-point charges. Force between multiple charges. Superposition principle and continuous charge distributions. Electric field due to a point charge. Electric field lines. Electric dipole. Electric fields due to a dipole. Torque on a dipole in uniform electric fields. Electric flux statements. Gauss law theorems and its application to find due to infinitely long straight wires. Uniformly charged infinite plane sheet. Chapter 2. Electrostatics, potentials and capacitance. Electric potential difference. Electric potentials due to a point charge, a dipoles and a system of charges. Equipotential surface. Electrical potentials, energy of systems of 2 points charges and of electric dipoles in an electrostatic field. Conductors and insulators. Free charges and bound charges inside the conductors, dielectrics and electropolarizations. Capacitors and capacitance, combinations of capacitor in series and in parallels. Capacitance and parallels. Plate capacitors with and without dielectric mediums between the plates. Energy stored in the capacitors. So chapter 3. Electric current electricity. So electric currents, flow of charges in metallic conductors, durability, mobility and their relations with currents, Ohm's law, electrical resistance, potentials, BI characteristics, linears and non-linears, electrical energy and power, electrical resistivity and conductivity, temperature, dependence of resistance, internal resistance of a cell, potential difference and EMF of a cells, combination of cells in series and in parallel, Kirchhoff laws and simple applications. Wheatstone bridge meters, bridge qualitative ideas only. Potentiometers principle and its application to measure potential difference and for comparing EMF of two cells, measurements of internal resistance of a cell, qualitative ideas only. Unit 3. Magnetic effects of current, magnetism. Chapter 4. Moving charges and magnetism. Concept of magnetic fields or state experiments by Safet law and its application to currents, carrying circular law, Ampere law and its application to finitely long straight wires, straight and toroidal solenoids, only qualitative treatment. Force on a charge in uniform magnetic and electric fields. Force on a current carrying conductor in uniform magnetic fields. Force between two parallel current carrying conductors. Definition of Ampere's torque experienced by current loops in uniform magnetic fields. Moving coil galvanometer, its current, sensitivity and conversions to ammeter and voltmeter. Chapter 5. Magnetism and matter. Interpreted current loops as a magnetic dipole and its magnetic dipole moment. Magnetic dipole movement of a revolving electron bar magnet as an equivalent solenoids. Magnetic field lines are magnetic field and magnetic elements. Unit 4. Electromagnetic inductions and alternating currents. Chapter 6. Electromagnetic induction. Electromagnetic induction. Faraday's laws induce EMF in currents. Lamb's law, eddy current cells and mutual inductions. Chapter 7. Alternating currents. Alternating currents peak and RMS value of alternating current voltage, reactance and impedance. LC oscillations, qualitative treatment only. LCR series circuit, resonance powers in AC circuits, AC generator and transformer. Syllabus assigned for practicals for term 1. First term practical examination will be organized by school as per the direction of Cbse. The record to be submitted by the students at the time of first time examination has to be include a record of at least 4 experiments and 3 activities to be demonstrated by teachers. Evaluation same. Time allotted 1.5 hours. Maximum marks 15. 2 experiments to be performed by students at times of examinations. That is add marks. Practical record experiments and activity 2 marks. Viva on experiments and activities 5 marks. Total 15 marks. Experiments assigned for term 1 to determine resistivity of 2 or 3 wires by plotting a graph between potential difference versus current. Second point, to find resistance of a given wire, standard resistor using meter bridge, or to verify the laws of combination series of resistance using a meter bridge, to verify the laws of combination parallel of resistance using a meter bridge. Point number 3, to compare EMF of 2 given primary cells using potentiometer, or to determine the internal resistance of given primary cell using potentiometer. 4, to determine resistance of galvanometer by half deflections method and to find its figure of merit. Point number 5, to convert the given galvanometer of non-resistant and figure of merit into a voltmeter of desired range and to verify the same, or to convert the given galvanometer of non-resistance and figure of merit into an ammeter of desired range and to verify the same. Point number 6. To find the frequency of AC hands with sonometer. Activities assigned for term 1. To measure the resistance and impedance of an inductor with or without iron core. Point number 2. To measure resistance voltage AC by DC current AC and check continuity of a given circuit using multimeter. Point number 3. To assemble a household circuit comprising 3 bulbs, 3 switches, a fuse, and power source. To assemble the components of a given electrical circuit. To study the variations in potential drops with lengths of a wire for steady current. To draw a diagram of a given open circuit comprising at least a battery, resistors, or use that key, ammeter, and voltmeter. Mark the components that are not connected in proper orders and correct the circuit and also the circuit diagrams. Syllabus assigned for term 2. Theory, core structures, time 2 hours, maximum marks 35. So Unit 5, Electromagnetic Waves, Chapter 8, Electromagnetic Waves, of Unit 6, Optics, Chapter 9, Ray Optics and Optical Instruments, Chapter 10, Wave Optics. The marks will be 17. Unit 7, Dual Nature of Radiation and Matter, Chapter 11, Dual Nature of Radiation and Matter, and Unit 8, Atoms and Nuclei, Chapter 12, Atoms, Chapter 13, Nuclei. The total marks were 11. Unit 9, Electronic Devices, Chapter 14, Semiconductors, Electronics, Materials, Devices, and Simple Circuits. So the total marks will be 7. So the total marks including all will be 35. Unit 5, Electromagnetic Waves. Chapter 8, Electromagnetic Waves. Electromagnetic waves, their characteristics, their transverse natures, qualitative ideas only. Electromagnetic spectra, radio waves, microwaves, infrared, visible ultraviolet, X-rays, gamma rays, including elemental facts about their uses. Unit 6, Optics. Chapter 9, Ray Optics and Optical Instruments. Ray optic, refraction of light, total internal reflection and its application. Optical fibers, refraction at spherical surface, lenses, thin lens formula, lens maker formula, magnification, power of lens, combination of thin lenses in contact, refraction of light through prisms, optical instruments, microscopes, and astronomical telescope, reflectings and refracting and their magnifying powers. Chapter 10, Wave Optics. Wave Optics, wave front and Huygens principles, reflection and refraction of plane wave at a plane surface using wave fronts, proof of laws of reflection and refraction using Huygens principles, interference, Young's double slit experiments and expressions for French white coherence, sources and sustains interference of light diffraction due to a single slit white of central maximum. Unit 8, Dual Natures of Radiation and Matter. Chapter 11, Dual Nature of Radiation and Matter. Dual nature of radiation, photoelectric effect, Hertz and Linus observation, Einstein photoelectric equation, particle nature of light, experimental study of photoelectric effects, matter waves, nature particles, de Broglie relations. Unit 8, Atoms and Nuclei. Chapter 12, Atoms, alpha particle scattering experiment, Rutherford model of atoms, Bohr models, energy levels, hydrogen spectrums. Chapter 13, Nuclei, compositions and cycle of nucleus, nuclear force, mass energy relation, mass defect, nuclear fissions, nuclear fusions. Unit 9, Electronic Devices. Chapter 14, Semiconductor, electronics, materials, devices, and simple circuits, energy bands, semiconductor, and insulators. Qualitative ideas only. Semiconductor diode, 1.5 characteristics in forward and reverse bias. That as a rectifier, special purpose p-n junction diodes, LED, photodiode, solar cell. Syllabus assigned for practical for term 2. Total periods it will be for 16. The second term practical examination will be organized by school as per the direction of Cbse, and Viva will be taken both internal and external observers. The record to be submitted by the students at the time of second term examinations has to include a record of at least 4 experiments and 3 activities to be demonstrated by teachers. Evaluation sim time allotted 1.5 hours. Maximum marks, that is 15. So 2 experiment to be performed by student at time of examination, that will be 8 marks. Practical records, experiment and activities 2 marks. Viva on experiment and activities 5 marks, total 15 marks. Experiment assigned for term 2. Number 1, to find the focal length of convex lens by plotting graphs between U and B, between 1 U and 1 by U and 1 by B. Point number 2, to find the focal length of a convex mirror using a convex lens, or to find the focal length of a concave lens using a convex lens. Point number 3, to determine angle of minimum deviation for given prisms by plotting graphs between angles of incidence and angles of deviations. Point number 4, to determine the refractive index of a glass slab using traveling microscope. Point number 5, to find refractive index of a liquid by using convex lens and plane mirror. Point number 6, to draw the current voltage characteristics curve for p-n junctions, diode in forward bias and reverse bias. Activities assigned for term 2, to identify a diode and LED, a resistor and capacitors from a mixed collection of searched items. Point number 2, use of multimeters to see the unidirectional flow of current in case of diode and LED, and check whether a given electronic component's example diode is in working order. Point number 3, to study effects of intensity of light by bearing the stance of the source on an LDO. Point number 4, to observe refraction and lateral deviation of a beam of light incidence obliquely on a glass slab. Point number 5, to observe polarization of light using two Polaroids. Point number 6, to observe diffraction of light due to a thin slit. Or point number 7, to study the nature and size of the image formed by a convex lens. Concave mirrors on a screen using a candle and a screen for difference distance of the candle from the lens or mirror. Point number 8, to obtain a lens combinations with specified focal lengths by using two lenses from the given set of lenses.